This is TWiT.
So, of course, I know we have tons of VMs that we use, and of course, I know lots of organizations that use a ton of VMs. They're hard to maintain, they're hard to patch, they're hard to upgrade. Running inside, sometimes you leave those holes of vulnerability. This is some of the kind of things that you're targeting with some of your software and some of your services?
Yes, but there's actually even a more fundamental issue. Security is it's a field somewhat at a crossroads right now. If you look at the data, IT spend has been growing at roughly around 4.5% a year. Security spend has been growing at 10.2% a year, so more than double. It's becoming a bigger and bigger chunk. Security losses are growing at 26% a year. So the only thing growing faster than security spend is security losses. This is irrespective of whether it's virtualized or physical or
right.
And it's true that defense is always harder than offense, but there's a fundamental issue. This is not solvable with sort of an incrementally improving. I think it goes back to looking at what's some of the fundamental problems structurally and architecturally that are at the root of a lot of these security problems. And I think Pat was onto something when he was asking about, should some of security be built in versus bolted on? And that's certainly part of it. But there's another part of it, which is just we are very heavily focused in this industry on chasing bad, I guess is the best way of saying it, meaning technology, using various kinds of techniques to try to identify malicious activity, malicious software, malicious people, users, and that is, by definition, you're always catching up because the attacker is constantly defining new threats. And the concept that we started to play with is there a way of flipping the security model to be about ensuring good rather than chasing bad. They're not mutually exclusive, of course, but ensuring good, saying, I know what applications I want to run here, and they're supposed to do certain things. This is my intent of my VMs, and I'll make sure that's all they can do. Is a very, very powerful concept because it gets rid of an enormous amount of attack surface. Things that do happen stick out. And there is a much richer context for security controls to make decisions. So we were very, very intrigued with this concept. This is an area we've done a tremendous amount of research and have built technology in, trying to build this into the virtual fabric itself. And it's a pretty substantial change in just the security model.
Right. So I think the interesting thing is that obviously people have VMs today. They're running applications on them. They're running their antivirus. They're running all the different services, their firewalls. Where does kind of AppDefense fit in here? Like how does it play out, and how does it kind of handle these types of services and these types of environments?
Yeah. So AppDefense is a project that I started here, I want to say about 3 years ago. It was a project codenamed Goldilocks. We built, and I've heard many people say, why couldn't you keep that name? We built technology into the hypervisor itself, into the kernel of the hypervisor. The hypervisor, which is really the basic fabric of really any cloud, has a few interesting properties to it. You're in a spot where you can actually see what's running, but you can also see what you provisioned to run there in the first place. It's also in a place where everything is automatable. It's just the infrastructure itself is software. So if you see what's running isn't what you intended to run, there's a million things you can do. You can re-image it, you can block it, you can snapshot, get more information. But the last thing is that we could do this without customers having to manage agents, install agents, right? We can do this using the hypervisor infrastructure itself, and we can do it from a safe position. A lot of challenges in security is if you successfully stop an attacker, at some point they're going to try to turn off or manipulate what's stopping them. And that's one of the challenges of doing security in agents. And so we sort of harnessed those three things, in essence, to enable this notion of a secure VM, which is that the hypervisor figuring out this is what that VM was for. This VM is actually part of the web tier of this app, the patient care system. And this is the software that's supposed to be on it. And these are the processes that are supposed to run. And it can figure that out on its own and essentially allow you to say, I want to make sure that what's running is no different than what you intended to run here. And if it is different, what do I want to do about it? Well, it turns out an approach like that is actually incredibly powerful at dealing with a whole range of threats, whether it's ransomware or lateral movement or command and control infrastructures. People use it on their applications, general applications, even on shared services like domain controllers like Active Directory or jump servers in banks. And what's interesting is the software has no idea about attack, has no intelligence about attacks. It's very smart about what you were intending to run. And at some point, an attack is trying to do something different than what you intended.
Right. So it sounds like almost like it takes a snapshot and it says, okay, this is the good. This is the last known good kind of state of my machine. And then, as the kind of things run, it verifies that kind of snapshot is the same, or if not the same state. And then if anything does change, it detects. I know I'm oversimplifying this, but is that kind of the baseline kind of thought process behind that?
In a sense, and in fact, whitelisting is not a totally new concept. Whitelisting has traditionally been sort of a list of approved processes that can run. We had an opportunity to do one better here, because what actually an application in a data center today is actually not a piece of software on a VM. It's actually 12 pieces of software on 20 different VMs networked together. They're communicating, web servers, app servers, database servers. So when you turn this thing on, the technology hooks into vCenter, which gives it an inventory of all the machines. It lights up the component in the hypervisor to watch what's installed there, etc. Now, what you have there is off-the-shelf software and custom apps. And so it uses a variety of techniques, not just to take a snapshot and assume it's good, but to actually figure out and map out the whole application. So for off-the-shelf software, we've licensed feeds from a variety of services to understand, this piece of this hash or this process is actually part of Microsoft Exchange version X or Windows version Y. And then for custom applications, we integrated into the CI/CD pipeline things like Puppet and Chef and vRealize and Ansible, Maven, Jenkins. So we integrated into the systems that people are using to provision their software. Those two things give us authoritative context of what things are supposed to be, not just taking a snapshot. And then the last piece, and we've invested very heavily here, we've been applying machine learning, not to understanding malware, but machine learning applied to understanding goodware. One of the things we do have is a massive base of VMs running in the world. So having machine learning looking at, well, what do various processes behave like normally in various environments? What does software normally behave like on the machine and over the network? So what you get in the manifest is not purely a snapshot, but what you now have is a list of applications running on your environment, divided into services, divided into machines. And you get an articulation of, for any machine, what's it for? Like, what's its purpose? What should run on it? How does it communicate? And all of that can be actually quite automated. So it's incredible, just getting insight into what things are for. But once you have that, you now have a very powerful mechanism for visibility, but also to essentially do attestation on your application itself. And what's the beauty of the approach is if you're patching or updating, the system can distinguish between, hey, this is just a newer version of the same software, or this came through your CI/CD pipeline, versus, wait, there's a change here. It didn't come from any of that stuff. It doesn't match anything. Like, something's different about what you're now suddenly running. For a critical application running in the data center, it's probably one of the best signals you have to start taking action.